Hello, thank you very much for joining me in this video. Today we're going to talk about Python, and we're going to talk about Python as in a general term, not just about a language. Typically when people thinks about Python, they think programming language. It's a programming language and you can do a lot of cool stuff. Well, that's true to some degree, but there is like a whole Python verse out there to explore. Something to know about Python if you're getting started with programming in general or just getting started with Python, it's to probably set some boundaries. And let me tell you that maybe this may come with some disappointment, but Python is not popular for creating graphical user interfaces. This is like window applications, panel-based applications, and things like that, or video games. Nope, not popular for that. It is possible to create them anyways, and but for some reason they're just not popular. And so if you try to approach Python from the perspective of creating graphical user interfaces or creating video games, it's probably not going to get you too far employment based or per industry standards. Okay. However, Python is very popular for all goes data, working with data, reading data, creating new data, transforming data, whether that data is structured, semi-structured, or unstructured. Structured data being tabular data, like coming out of a CSV file, a comma separated file, like tabular data. Um, and semi-structured data being like JSON, XML, like there are attributes, but they can be all over the place. And unstructured data basically meaning media files, image files, um, audio files, video files, or even text, just plain text, books, whole books. That can be thought of unstructured data. So Python is very popular for that, and it's very easy to program for these kinds of things. Services, of course, creating applications that will be called as a service, probably from a website, or but could be others. That's very popular. And research. Well, if you're good at working with data, you need facts and data in order to conduct research and conduct statistics and that kind of thing. Okay, so let's head to the language part of Python. It is a high level programming language. That means that there is an interface between you and the CPU. You don't have to be concerned about working with specific machine instructions or anything like that. It gives you a foundation where you just work high level things. And for instance, we have string operations, right? And this is text. Working with text in Python is easy, is beautiful, is simple. You can do a lot of string based things. And doing arithmetic or set like math operations, that's very easy with just the Python language. In and of itself, the Python language offers you a lot of features to work with text, strings, arithmetic, and set like operations. So that's very good. What's more difficult to do is other things like checking for a file in your system, checking for the date, doing date operations, and so that then you can do further work that doesn't come packed with the language, but when you install Python in your computer, it will you will have the out of the box the standard library of modules. Okay, so these are modules that you implement in your code. They're not part of the language itself, but they include functionality. You import them, and then you can use date functions, and then you can use operating system directory operations, create a directory, check the files in a directory, delete a file, and so on. And so it allows you to do actions. The standard library of modules creates an abstraction layer where you start thinking about the actual purposes and objectives that you have in mind, like working with files, working with directories, or working with dates, and so on. And if the standard library of modules that comes out of the box with Python was insufficient, you have the modules created by the Python community. And these modules are created by, could be companies, could be organizations, could be people working in universities on their PhD and things like that. And so they create these modules and they make them available through the Python package index. Okay, the Python package index is a repository of Python modules created by the community and made available that you can download and use in your Python code. Okay, how do you download that? Well, there is a piece of software also developed by the Python Software Foundation called PIP, Preferred Installer Program. So if you need to use any of the modules created by the community, and trust me, you will, because this is what has made Python so popular, then you're going to use the pip installer to download this, and then you're going to use them as a module. You're going to use the import keyword, and you're going to use the name of the module that you downloaded, and now you're going to have access to a bunch of functionality. So there are some noteworthy modules that you can download through the preferred installer program through the pip, such as pandas, numpy, tensorflow, keras, pyspark, matplotlib. Okay, I think you can read. But let me tell you something. Remember that we said that Python is a high level programming that has like an abstraction layer between you and the system, and you cannot work with the CPU directly or anything like that. Well, that can change a little bit when using modules. So I'm going to put a little asterisk here to indicate that this might not be 100% the truth. Because when you start working with some of the modules, some of them may have direct interaction with the hardware. Let me tell you, for example, we have quite clearly PyTorch and I believe TensorFlow. Um, in order to use them to the best of their capacity, you need to have an NVIDIA GPU, a graphical processing unit, basically a video card, as some people call them, that is CUDA enabled. CUDA is an interface between C language and the GPU so that you can use the functionality. Basically, PyTorch and TensorFlow are a couple of modules used for machine learning and AI. And in order to create machine learning models, you need a lot of parallel processing. So they started experimenting with the GPUs because the GPUs were created to render 3D graphics and so on. And so now they're using them to compute machine learning modules fast. What used to take weeks or months to compute, it can now take hours and even less, thanks to leveraging GPU technology through Python modules such as TensorFlow and PyTorch. Other noteworthy modules here, Matplotlib allows you to create charts on the go. Pandas allows you to do a lot of data analysis and data cleansing. NumPy, like the name indicates, is about numbers and computing numbers in matrices. You can very easily take, for example, a media file like an audio file and something like that and invert it and play it backwards, or you can chop it, lower the bass volume, you can make alterations, because in the end a media file is just numbers. It's an array of bits and bytes that you can work with very easily if you use NumPy library. We have Boto 3 and the Azure libraries. This is for integration with cloud services. So just look at this. Python allows you to integrate to cloud services, allows you to do machine learning, allows you to create charts on the go, to do data cleansing, numbers computation in vast amounts of numbers, and so on. And it's all thanks to the modules that are created by the community. But if there are two modules that I want to really stop by and pause, would be PySpark, which is very highly in demand. It's basically using Spark over Python. Spark is data analysis, data engineering, working with a lot of data, but Spark allows you to do parallel computing between computers. Okay, so that means that using Python, you can have a cluster of servers or computers running a query or running analysis on vast amounts of data in parallel using many computers. And that's just a scratch in the surface of what Spark is. And so PySpark is something that we're going to go over the next videos. And the Transformers library. So there is an organization, a website called Hugging Face. Well, it's an organization where they store machine learning modules for sharing them. It's a repository of machine learning models so that everyone can use them. Okay, so by downloading and installing the transformers module with pip, then that gives you access to the repository of machine learning models available in Hugging Face. So that means that you can create, for example, a service application here, probably like a Flask application, like a web server that in the backend is going to have artificial intelligence functionality for you to use. So that's one of the things you can do with transformers. You can also fine tune your model and things like that. So Python is what it is right now, thanks to the community. Because even though the standard library of modules is very useful and you can do a lot of good things with that, the really crazy things, the really uh, big stuff that you can do that Python has become so famous for is available thanks to the modules created by the community. So again, just to recap, it's a high-level programming language, that's Python, that allows you to do a lot of string operations, arithmetic, and set-like mathematics, and it includes a standard library of modules to work with dates, to work with files, to work with many other basic things. However, the community creates noteworthy modules there, and you can download those through the pip installer. And what pip does is to check the Python package index repository, and it downloads whatever it is that you need. This is all supported, all of the Python language development, the repositories to store these modules and so on. This is all supported by the Python Software Foundation. Okay, so they oversee the development of the Python language, the platform that runs Python, the modules, making the modules ready for the public and all of that. They manage the Python package index and so on. One more thing to understand about Python is that you cannot just create Python code and run it. You can obviously write Python code in a text file and so on, but you need to install Python in your computer. And Python is available in most popular operating systems: Windows, Mac OS, Linux, Raspbian. As a matter of fact, Python has been pre-installed in a lot of Linux distributions, including Mac OS and so on. And just to show you, I opened this question in the unix.stackexchange.com forum. Here's a basic answer to this question: on which Unix distributions is Python installed as part of the default install? And Red Hat Enterprise Linux and its close relatives, Fedora, CentOS, Scientific Linux, Oracle Linux, will always have Python installed, since the installer and many core tools are written in Python. Also, Ubuntu comes with Python installed. Debian currently ships with Python, and Mac OS X has shipped with Python installed by default, going back to at least 10.3 version. So there you go. It comes pre-installed in all of these, and not on Windows. However, it is very easy to install this on Windows. You just need the store. To go to the Microsoft Store, you type Python there. I want Python. And Python is on its version 3 or later right now. You can just choose the latest that shows up there. Python 3.12 by the Python Software Foundation. You click Get, and it's going to install it. And you're going to be able to right away start programming in this language. In my experience, it's been a little difficult to learn Python because I wish somebody gave me this information. Somebody gave me a quick introduction on what is Python, what should I expect. I started doing video games in Python, for example, and learned that I wouldn't go too far, but then I learned about the machine learning things and all of that. So on our next video, we're going to start doing some Python code. We're going to start doing some tips and tricks, and eventually we're going to do a deep dive into PySpark. And I hope that you enjoy this video and that you join me on the next one. Thank you very much. Have a great day.